welcome. Today, our goal is really to discuss the ML test score here with Skylar. Our goal is really to increase our reliability and decrease the maintainability in the long-term process of our ML project. And the ML test score seems to be a possible way a good strategy for it. Just to recap, 2 weeks ago, we had Tim Blazina and Laszlo here in our reading group, other valuable members of our community, and we're really going deep in these. How can we really apply software engineering practices to MLOps? And now we have here Skylar, who has some experience, as you'll see. So Skylar, without further ado, can you give us your best elevator picture so that we get to know you a little bit better?
Yeah, and I'm going to walk off camera real quick because I'm pouring water for tea. So I started my career at Google working on ad policy enforcement, so doing a lot of like fraud detection like stuff. And then I worked on large scale search and recommendation for several years at LinkedIn, where I kind of operationalized the ML test score. After doing that, I've been working for the past year in a space called digital phenotyping. So essentially trying to predict people's mental health like through their phone usage. So I've worked on a lot of different types of machine learning problems and whatnot. And I've seen teams at lots of different scales. I've seen products, from the inception all the way to like international launches. So I feel like I have like a lot of insight into sort of like how things maybe vary across different like domains and whatnot. Excited to talk a little bit about how applying the ML test score went in LinkedIn.
Awesome, and congratulations on your path until today. That's awesome. So we can really jump right on it. Just folks, feel free to interrupt us at any time, ask your questions as well. I have some to Skylar prepared, but we'll see how all this will go. And okay, so my first question to you, Skylar, is really, can you really throw some light on how was the process regarding the operationalization of the ML test score at LinkedIn? We know that these good practices are awesome, but we still need to really be careful because we still really need to bring value to our customers.
Mm-hmm. Yeah, definitely. So, I think the context that's maybe important for this, for a long time at LinkedIn while I was there, constantly the velocity of AI teams was kind of called out as being a bottleneck. And there's lots of things LinkedIn did to try to kind of account for that. So some folks may have heard that LinkedIn started an AI Academy. My team actually started that at LinkedIn as well, where we taught like engineers who didn't know AI, like here's how you kind of like apply machine learning and whatnot. And the idea was supposed to be like, hey, let's like try to make the machine learning teams not be such a bottleneck by democratizing it a little bit. But still, it just continued to be like a big pain point. And one of the big issues was that, we didn't have good infrastructure and whatnot in place. Everybody had built their own bespoke things. And some folks may have heard of LinkedIn's efforts called ProML, which is really their sort of like push to like make machine learning work productive. And they had like the grand claim that they were going to make machine learning work like twice as productive. At the time, that promise was not fulfilled, very far from it. Some people would say it made us less productive at that point. Really, we were kind of in a place where we needed to understand like what was really holding us back and how could we like really resolve that. And my manager at the time was talking about how we could measure sort of things within our teams. And I had recently read this ML test score paper, and this is probably about 2 years ago. And I said like, hey, this is something we could maybe apply to the sort of models that we have and get some insight into where are gaps and whatnot. And so I first just worked on applying this in the teams that I worked closely with. It was about 5 teams that managed about 10 to 15 models, had like 40-ish machine learning engineers. And it was pretty easy because I was familiar with most of the models and I knew how basically all the pipelines worked and whatnot. And we're able to identify some patterns of things that we like consistently were not doing. Identify some things that, some teams had done pretty well and other teams needed to learn from, et cetera. And after that, I kind of worked with some project managers at LinkedIn, and they kind of scaled this across all of the machine learning teams.
Mhm.
And from that, we were able to basically, I think it was very useful as a tool for leadership, because we were able to essentially say like, hey, look, here's like an aggregation of like all of the models we have basically across the company. Here's the things that nobody's doing. Here's the things everybody's doing. And it helped us get some insight into where should we place our bets? Where do we need to really like place our efforts to kind of like maximize our productivity overall?
Yeah.
So I think like that's like the context.
Okay, great. Just a follow-up question on that. What kind of bad and good, probably the bad patterns first, if you noticed it across your teams?
The bad
You,
patterns. Yeah.
yeah.
So I think like I think the biggest thing that I saw that was a bad pattern, and I don't know if this is actually captured in a test exactly,
Mm-hmm.
but I think like one of the challenges we had, LinkedIn has a virtual feature store, and essentially what that means is like online and offline. So like during training versus serving, we like implement features differently. So it's
Mm-hmm.
like, we have like code that's implementing it for serving, code that's implementing it for training. And so there's a lot of like train serve skew there. And so I guess this
Yep.
might fall under sort of like testing your features, but very often this caused problems, where essentially you would do some experiment offline, and say like, oh, this model looks great, and then you'd put it online and it would be terrible. And
Yeah.
there's a lot of teams that went through a lot of churn there.
Mm-hmm.
I think another one that's like semi-related is really it is captured directly in a test, the correlation between your offline and online metrics. Since I worked in search and recommendation, often one of the challenges is like if you change like your retrieval algorithm, you don't really know how that's going to like affect things. If you aren't careful with how you can make estimations and whatnot, but there's like essentially like you can't estimate the counterfactual if you didn't do some work ahead of time to make sure you like can estimate that with like, I don't know, inverse propensity scoring and whatnot. So there were a lot of teams that weren't using like inverse propensity scoring or doing some sort of like random bucket. And so there wasn't a way to like actually like estimate in a robust way like the offline performance. And
Yeah.
so you kind of were just flying blind of just like this model, like I like this model. I think it looks okay. So let's put it in production.
But
And so I think
didn't
that
you
was
A/B test it? You didn't
yeah,
A/B test it?
we'd A/B test it, but when thinking about overall productivity, like you have a limited number of models you can A/B test at any given time, given your traffic. And
Okay.
if you're using those slots for models that like you could have known were not going to do well, you'd prefer to catch that earlier.
Okay, got it. How do you do that, by the way? How were
Yeah,
you doing
so
it beforehand?
yeah, so beforehand, I don't think we were doing a good job of it at all. Um, I think the technique that is most interesting to me is to
Mm-hmm.
essentially use inverse propensity scoring. So you can basically add a tiny bit of randomness to your results, and then you can basically log like the propensity that something would be shown to the user. And then offline, you can kind of like use that to reweight things when you're evaluating. And then you can get like a better estimate of like what the actual results would be if you train a different model.
Okay.
And so that's something that can be helpful. But yeah, I think like a lot of times I see people just aren't doing anything there, and they're just
Yeah.
like hoping that it's going to work, and you're going to have like very like biased results in search and recommendation if you don't do something to account for that.
Okay. And what about the good patterns that you identified?
Yeah, so I think like I was lucky that in the group of people I was working with, there was a lot of like pretty strong engineers around that really took a lot of care into like at least some aspects of things. So I think like in general, definitely the tests that like I think people like always nailed. People always tuned hyperparameters. I
Yeah.
often find that like I never found a case where someone like wasn't tuning their hyperparameters. I always thought it was like more of a waste of time, in that like people were spending so much time on that and not like all of the other stuff. But at
Mm.
least like that's something that they handled. I think that let's see. So definitely, I think in general, like we did have some sense of like prediction quality has not regressed. I think most of the time, but it was like very,
Yeah.
very. It wasn't as good as you might want it to be.
Mm-hmm.
In the sense that like we essentially were tracking like business metrics, and so like we could tell if like the performance regressed pretty easily from that. I would say that model quality being validated before serving definitely is something that like everybody tended to do. I think like models being debuggable, that was like at the time LinkedIn was like very LinkedIn historically has like largely focused on like large linear mixture models.
Mm-hmm.
So they're just like inherently pretty debuggable. And so they're pretty easy to debug. Definitely, yeah. So I think like those are probably like the key things that like were done pretty well.
Okay.
But I think a lot of the stuff around like testing your data, making sure like your pipeline is tested in some way, and things around staleness and train serves view. I think like those were kind of misses that we had.
Okay. I have some questions regarding it as well later. So the next topic can be regarding when you were implementing the ML test score and when you got it right across the teams. What was the ROI of such execution, and when did you started to really take profits from it?
Yeah. So I think like I don't after like doing that exercise, I don't actually think that like this was like something that was like useful in an ongoing fashion. I think it was useful as
Mm-hmm.
like more of just like a let's do an inventory and see where we're at. And I think it was
Okay.
mostly useful like in aggregate to see like, hey, if we're gonna make some bigger bets, this is a tool we can use to get some information on like where like a lot of the teams are struggling. And so the ROI really came. LinkedIn basically, that leadership had like made a declaration that like we're going to fix AI productivity. You have a year to do it here, and we used this ML test score to come up with a set of OKRs basically that all AI teams had to meet within a year.
Okay.
And very much those OKRs like aligned with tests. It wasn't like 100% because I don't think anybody should take this like there's a flavor of like all abstractions are arbitrary but some are useful. Like these tests are
Mm-hmm.
some abstraction that someone came up with, and I think there's useful things here. But the reality is like some of these things you might look at and be like, okay, this isn't important for the problem I'm working on. And
Yep.
so but we were able to use this as a tool to say like, hey, here's something that maybe we should take a deeper look at. And we kind of like match that with sort of like where we want our core competencies to be as a company, and we were able to develop OKRs from that. And so I'll say the ROI was like fairly mixed. And so for those of you who like heard the coffee chat with Alex Patry, he's like one of my mentors at LinkedIn. He talked a lot about like sort of a lot of the stuff he talked about kind of came from those OKRs. It was work that evolved out of those OKRs, and they're way more productive now, like 2x basically. So
Damn.
there's definitely a lot more productivity there, but the ROIs across the company was definitely mixed. And it's hard to exactly say like whether the ML test score, the OKRs, or like what the miss was exactly. Um, my general suspicion is that like a lot of people didn't like the decree from leadership to say you need to fix productivity, and I don't think people leaned into it.
Okay.
So like the teams I was working with, we leaned into it pretty hard, and I don't think other teams were like as like gung ho about like really fixing it. I think they just wanted to keep doing what they were doing, and so that the outcome seems not surprising to me.
Okay. I have some follow-ups over what you just said as well. The authors of the paper say that they believe that the relative importance of the tests to team will really vary depending on their specific priorities, right? And I think you
Mm-hmm.
mentioned it a little bit. However, have you found some tests that were usually more important? And if yes, which ones?
Yeah, so some of the features that I think like everyone tended to find important. training and serving aren't skewed. I think that that's a problem that like a lot of people faced and they were very familiar with, especially because we literally the way we like set up our feature store at LinkedIn like made that like a very real concern. Another one was that I think like a lot of times there were places where models had essentially, oh hey, you have the ones
Yep.
sort of like a
exactly. Yeah, for sure.
I think I added another one, training and serving, not skewed. But prediction quality is not regressed. That was an important one for a lot of teams. I think like at LinkedIn, and I think this happens at a lot of companies where, somebody gets really excited to like launch a new model and they go move on to another thing rather than sort of like continuing to like maintain that model. And so there was a lot of like rogue models basically across the company. And I think people got really annoyed when like, someday a PM comes over and be like, why does this model suck now? It was awesome like 3 months ago. And so like having a way to like get insight into that, I think people definitely really wanted. Certain models can be rolled back. This was definitely like a very important, I think everybody understood the importance of this. I don't think there was anywhere where we didn't have this capability though.
Okay.
So it was like we were always able to do this, but I think everybody understood that you might launch a bad model. And so you need to be able to kind of go back. And so kind of coming back to like the whole like onus or the whole like premise behind which we like started using the ML test score was that we wanted to improve productivity. A lot of our engineers were really just doing feature engineering. And it took so long to add new features. And so everyone was really focused on how can we add features more quickly. And I think the only other one here I didn't mention yet, offline online metrics correlate. I think, people always, I think everyone I talked to always had the experience of like seeing something look amazing offline and then put it in production and then it doesn't do well. And so I think everybody like really, I think there was always like, people thought once they had good offline metrics, they're like, my job's done. I put it in production and then I just let it go. And I think there was like people's hope was kind of smashed after they saw that the metrics didn't correlate, and it's pretty demoralizing. So yeah, I think like a lot of people like really understood like the importance of that.
Yeah. Regarding the test features can be added quickly. I'm not sure. We've been reading a lot of like the importance of continuous delivery and how important it is to iterate really fast. Like the Google usually every year does these reports that they usually say that they are doing deployments every hour and whatnot. Do you think this goes hand in hand with this, like to give the opportunity to ML engineers or data scientists to really iterate fast on their model?
Yeah. I think that they definitely do go hand in hand, and I think there's a flavor of like going back to that quote I said of like, all abstractions are arbitrary, some are useful. It's like there are other tools you can look at. So just like having that setup of like being able to deploy every hour is very useful. I think in general, like the more that you can, I think in general, like a lot of data scientists or ML engineers workflow, especially at a large company, has a lot of like overhead in it in terms of like, oh, I want to do this new thing. Okay, now I need to talk to this person. This person needs to enable something. Okay, and then I need to talk to this person. And it's kind of like you can inch things along, and things take so long to do, not because the actual work takes a long time, but because there's like a lot of waiting in between. And so the more that you can kind of give people agency to do things, I think like the faster you can move. But there's of course a trade-off here of like risk. And so like if you are working like in a risky domain, maybe you do need to have that waiting time because somebody needs to approve it because you absolutely cannot like handle the risk. But I think like, most of the time, I think a lot of people that I talk to are working in a consumer space. And I don't think the risk is actually as high as people think it is. And so you can afford to be a little bit riskier, I think.
Okay, great. And
see, there's a question in chat. I don't
know
if we want to do that.
Let me see. My bad. Guys, feel free to interrupt us. No problem. Okay. Let me see. Thomas,
yeah, so Thomas asked, did you leverage any of the MLOps maturity criteria from Google or Microsoft along with the ML test score in this exercise? At the time, I don't think I had come across those. I don't know if they were released at the time. I remember one of these, I think Google's I think was a successor to the MLOps, which the ML test score, if I'm remembering correctly. So I think it might have like not like been released at the time. But I had looked at like some other things that had similar flavors of this, and I think today there's like, I don't know, like 5 things I could probably point to that have a similar flavor to the ML test score. And I think in general, like I don't, these aren't like very like precise tools, you know? Like this is literally like some kind of like checklist where you're gonna like score something. It's very like rough and coarse grained. So I think like, you know, taking a few of them and just getting a sense of, you know, how they, getting a sense of like how you measure on all of them might just give you a little bit more information on like where you consistently missing a mark or something. But yeah, I think like for our purposes, like I think really this was good enough to just like leverage. Once we aggregated it up across a lot of teams, this seemed to be good enough to give us like some direction. Because I think at the end of the day, like I don't think you should follow this thing like to the letter. You know, again, it's a tool. You use it to like help you understand like where you're at. And you need to compare that and contrast it with like, what do you want your core competencies to be? What do you think is actually important for the problems you're working on? It's maybe a challenge that there's a little bit of a, sometimes you might not think a test is important because it's really not important for your problem. Or sometimes you might not think it's important because you don't understand why it would be important. So you need to make sure you like suss that out. And so like, I think if you look at other, I think the things that tend to come up in all of these like test scores and maturity guides, those are the things that you can be fairly confident. Okay, this is something to like, this is something solid that I should like be paying attention to.
Okay, awesome. Regarding, by the way, so there's also another question here in the chat regarding that. Do you have the links regarding these maturity criteria, Skylar?
Oh, it looks like Thomas just.
Oh, someone linked. Oh, great. Awesome.
Thanks, Thomas.
I'll copy that to Slack as well, probably.
Great. Awesome.
Regarding the rolling back test, how did you guys implement that? For example, a possible tool that I usually really hear a lot of people now talking about it is like Argo, in particular, Argo rollouts. Or did you create an in-house solution?
Yeah, so at LinkedIn, like everything is kind of built in-house.
In-house,
and so like,
okay.
Yeah, the exact solution depends on some things. Like, so if you're deploying your model as one of the nice things about deploying your model as a container is like its dependencies and everything are separate. And so really the only solution that you need to like roll back your model is you need some configuration or something somewhere, a layer of indirection between like the things fetching model results and like the actual like model server, right? So if you have like a config, let's say it says, I'm going to use model 1, you know, then rolling back is just changing that config. And largely that's kind of what LinkedIn used. It gets trickier though when you have a model that's like embedded in a service in some way. And this is more common in like search and recommendation where you like need data locality. So it's like if you're doing like a retrieval phase and you have a model in that retrieval phase to get like the initial set of documents you rank over, like, you know, LinkedIn has like hundreds of millions of people that we might need to rank over. And it's like, well, you're not going to do that all on like by like fetching features from a feature store. You kind of like shard it out and you need that to use that data locality. And so our models like were on the same host. And given the technology that was already there and infrastructure that was already there, it wasn't really feasible to like deploy them totally independently. And so they were kind of like deployed as part of the service. And that meant that rolling back the model was actually rolling back the service itself. And so that was a case where it was much trickier. And we definitely experienced a lot of pain and problems with that. And I don't think that in my time there, I don't think we had a great solution, but I hope that they figured it out at this point.
Awesome. Okay. Now changing the topic a little bit, in another like really well famous paper, I can bring it up here as well. So it is the 2015 one. The 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 name Hidden Technical Depth in machine learning systems. There's this passage that I would like to give you some context on a real use case to know which steps should we take in order to solve this situation. So if, the authors talk about pipeline jungles, right? Jungles of scrapes, joins, and sampling steps, often with intermediate files output in data preparation. And this is probably usually common in pre-processing or even feature engineering. So, Skylar, assume that you on board on a ML project and your team has built basically a pipeline jungle without many unit and integration tests. However, the code is already modular in .py modules, okay? But we still have some tendency to go back to notebooks to check its behavior since we don't have a lot of tests. And also you have an MVP model ready to be A/B tested and deployed. What would you do in order to reduce the technical depth that you have here in these pipeline jungles, and if the ML test score would help?
Yeah, so I think, one, I'm not a big believer in one size fits all strategies. And so it's like, we can describe this situation, but there's a lot more details that are missing from this example to like say exactly what we should do. But I think like some broad like things that I would think about is like, one, do I have confidence in the data? That's the first thing that I always want in a project, because if my data is like not describing the things I think it's describing, like I'm already hosed from day one. Doesn't matter what else I do. And so generally, I first like start looking at like making sure my features are tested and whatnot, making sure that that stuff's there. As far as like getting out of this pipeline jungle mess, Laszlo, very active in the community, has a great series on refactoring DS code. Highly recommend folks take a look at that if they haven't. But essentially, like if you can kind of start refactoring the code to get out of this pipeline jungle mess, that's useful. But I would focus like as you're refactoring on getting to a simple baseline. How can I like kind of like take the spirit of what this model is currently doing and make like the simplest version of it? I'm talking like, can I make something that has one feature, simple linear model, and push that out? And then once you have that, you should be able to verify that, hey, the previous thing it does better than the baseline. And then I think like slowly over time, you can start like refactoring more of those bits in as you go along. But, I think like, making sure you're confident in your data, making sure you have like a simple baseline, and then slowly evolving that baseline to the sort of like full thing. And, in those steps, following a lot of the tips that Laszlo has in his guides for refactoring DS code, I think that gets you like a long way.
Awesome. Okay. Now, also, the papers, the authors also say another couple of things. For example, regarding, for example, you kind of mentioned it a little bit regarding the confidence that you have on your data. Some tools on that might help might be like, for example, Great Expectations, for example. However, those kind of tests might be as well a lot. You can have a lot of false positive alerts, which are instead of giving you a value, they're just being a little bit annoyed. Did you, when you were implementing the test ML score, did you also feel this way, or how did you overcome these kind of alert rates over your features?
Yeah, it's a great question. I think like monitoring and alerting and machine learning and data has always been like you see all these startups that are like, that will tell you like, hey, you don't need to do anything. You just kind of like point us at your data and then we're going to figure out all the thresholds and everything. And in my experience, those have never worked as well as I want them to. And I think like the reality is like, I'm kind of like at the opinion at this point that like this is one of those things that you're going to have to iterate on. It's depending on sort of like how your data tends to shift. So for instance, like e-commerce data is going to shift in a different way than like LinkedIn's sort of like profile data. And so you kind of have different needs across like your different data sources. The way that I kind of like go about this is like thinking about like the thinnest thing you can do that gives you the most confidence. So like, what can you do that's like very high ROI, very low effort, very high reward. And I think I'll need to find a reference to this, and I'll share it in the Slack if I can find this. But there's somebody like wrote a guide of like 5 to 7 like just very basic data checks
Mm-hmm.
that I've found like in practice work fairly well. And it's things like checking like how often a column is missing, checking just very basic statistics about the data. And that I feel like has given me a lot of bang for my buck to start. Um, and so I would say start there because that it's so simple to do. You can implement them as like SQL queries, or whatever
Mm-hmm.
query language you need to use. But it's so simple to implement, and you get a lot of value out of it. It'll tell you like if something's really going to blow up. Um, and then I think it's worthwhile to like inch your way into like more sophisticated forms of monitoring. And there's ways to like set these thresholds in an automated way. Like most people are probably just going to like basically more or less eyeball what the data has looked like over like
Yeah.
some period of time and say like, okay, if it goes up this high, that's where the threshold is. And so it's like it's a very like it feels more art than science setting a threshold right now. And so I think like to some extent, once you get to that layer or to that level, I think you should accept that this is something you're gonna have to iterate on, and you're gonna have to like watch to make sure that you're not setting the threshold too loosely, and also making sure you don't set it too highly. I'm always like actually more afraid of setting the threshold too strictly in that once you once you like annoy engineers, once they think that something has like too many false positives, they just stop looking at it. And I think that
Yeah.
that's the most
Yeah.
dangerous thing that can happen. And it
Mm-hmm.
doesn't matter if you fix the threshold, like people just lost trust in it. And I'm a strong believer that like trust is hard to gain, easy to lose. And so definitely like that's something that I think a lot about and being careful with that.
Yep. Do you still remember? For example, you mentioned like 5 to 7 examples. Then it would be awesome if you could like send it to Slack that reference.
Yeah. I'll find
Yeah,
that
for
link
sure.
and I'll send it.
Awesome. Okay. But was, for example, missing values one of those? Missing like data missing values over your
Yeah.
features, for example. Mm-hmm.
Yeah, and so it
Okay.
really just like setting like a simple threshold on like how much missingness should you have. I think another one of the tests was basically ensuring like uniqueness of keys. This is especially important for people who aren't using like I think like there's a lot of places I'm seeing where people like set up there's a bit of like a lot of these data problems happen because of like bad data models. Um, but one good test is like making sure keys that you think are unique are actually unique, and you would really hope
Yeah.
that that's the case. Um, although maybe over a beer sometime, I'll tell you guys about a story about when LinkedIn didn't maintain primary keys in their database. That was a fun day. But yeah, so
I think we have time. Skylar, you can go ahead.
yeah, LinkedIn has a database called Espresso. I believe it's open sourced, but essentially, there was one day where I noticed something peculiar, where like the keys that it was generating, that were it had a feature like every database of like maintaining a primary key for you, and I noticed
Mm-hmm.
that it was generating duplicate primary keys. And this is like one of those issues that it's a little bit hard to detect in that like if two things are writing data to the same primary key, they're just like overriding each other. And uh, it took a very long time to fix this, like a
Yeah.
year. It wasn't happening like very often. It wasn't often enough for people to notice. But we found that out because we did this uniqueness check at LinkedIn. So we and so like I think like there's a almost any assumption you can make, no matter how reasonable it seems, it will break on you someday, I think. And so like
Sanity
we
checks.
thought,
Yeah.
yeah, It's a trust but verify. So like we were assuming that our database was going to maintain these primary keys, and we added a check just to make sure, and it was not. And that actually caused problems in our downstream training that we were able to fix, because we had bad corrupted data basically. And so once we removed that, we were able to get some better models out too. So yeah, so I think on the data and model monitoring space, there's a lot of low hanging fruit. So like I think like for a lot of people, like I've been in this like space for a long time at this point, and I even get overwhelmed when I look at all of like the MLOps stuff, and it's very upsetting to me, because I think like a lot of people just get lost in a sea of like, which ML monitoring solution do I need to pick? Is it a Rise? Is it Big Eye? Is it blah blah blah? And I think like maybe you can just start with some very simple data checks, and that'll give you a lot of value.
Yeah, moving average, for example, across your features and checking the distribution as well. Values, standard deviations, so simple. Yeah. So I also have some now regarding a little bit of the model. I'll pull the paper over. So there's this passage, the paper regarding testing the correctness of an ML algorithm, which can be really difficult depending on the use case. For example, they say this example, for example, regarding an RNN, when solution is to make assertions that specific computations of their algorithm are correct. For example, specific parts of an RNN were executed exactly once per element of the input sequence. Other simple solution might be, for example, just check that your loss function is decreasing, but that sounds really simple. In your hand, how do you usually test like the ML algorithm? How meticulous are you with this?
Yeah, so I'd say that the answer is like not very. So one, I'll say that like I'm not really in the business of making new ML algorithms. I might kind of like take existing architectures and tweak them a little bit, but like I'm not publishing research, and I have no intention of doing that. So I'm not tweaking like architectures a whole lot. Like, there are several implementations of like RNNs that are like already like battle tested and whatnot. And if I want to use an RNN, I'm probably going to reach for one of those rather than try to roll my own. And so I think like the first thing is like, don't write things you don't need to. And if you're trying to like fudge around and make a new type of model, really ask yourself whether you actually need to do that. I think like a lot of people end up doing it because it's fun and exciting, and it's like kind of like not invented here. You want to make something your own. But I think there's a level of making sure that's something you really need to do. But as far as like what I would do in that situation, Karthi has a great post on essentially training neural networks, where he talks about like a lot of like tests you should do essentially. And I think like following those guidelines are actually like a very good sort of like ROI. They're not like super high effort, and they give you good sanity checks. So it's things like make sure your model can overfit on a batch. So you should be able to like make your model perfectly predict one batch. If you can't do that, then you screwed something up. You can actually you can actually figure out like if you randomly initialize the models, roughly what the sort of like output should be, to start in expectation. You can, so there's a lot of these checks. I don't remember all of them off the top of my head, but I would say consult that. That's like the first thing that I would look at. Looks like there's another question in the chat too. And thanks to
I also brought that one up.
Oh, cool.
Yeah. By the way, I'm on Dimitri's account. By the way, you guys, if you send DMs, that's no problem. There's a question in the chat as well. Are there specific model error analysis tricks to employ to debug models?
Yeah, there's two, and I'll share a couple of videos of that I think are like very cool on like how to debug models essentially. Some of the tools that I've used at LinkedIn, I was using a lot of like deep learning, and so we're using like integrated gradients to do like model explainability. So very often, like in search and recommendation, the question that we're trying to answer is, hey, this result was shown above this other result. Why? And integrated gradients is like a great framework for saying like, here's the score of the thing we thought should be higher. Here's the score of the thing that was higher in reality. So integrated gradients could tell us exactly like why it was ranked higher. So that was very useful. On top of that, I'm a big fan of just like pretty manual error analysis. So just kind of like go through like your data, like basically just take samples where your model is like getting your predictions wrong, and especially places where it's getting it very wrong. And then really just like try to slice those errors by different things. I usually go through and like very manually tag things. So I'll kind of like look at the data and try to like take notes on like what the what sort of observations I make. So I might make a tag related to like what the actual predicted class was or what the actual score should have been. I might make a note about features that was missing and whatnot. And so as you can like slice things like that, you can kind of get a sense of like what are like common error modes of your model. There's ways to kind of automate that a little bit. So like one of the videos I'll send, there's somebody that talks about using like essentially you train a model predictor, a model performance predictor. So you have your model that you want to understand and study, and you essentially train a model on its errors. And you can train like a simple decision tree, and then that decision tree is interpretable itself, and you can see in the decision tree where your model is making errors the most. And so that's a cool technique. And there's another video from a guy, I'm forgetting his last name, Vincent something, but very active in like the NLP space and whatnot. Has a lot of great talks at PyData. But he talks about sort of like creating like a rule-based or heuristic models alongside with a machine learned model, and then iterating between them. So you can essentially like use the rule-based model and the machine learning model, find the places where like they disagree with each other, and then use that to kind of inform what new rules do I need, but then also use that to inform what fixes do I need to make to the model. And so those are, broadly speaking, some of the techniques I've used.
Got it. And what if it happens like those rules that they were missed? It was, for example, load small like data samples. You do like data augmentation or something to tackle it?
I mean, it really depends on the setting. It's hard to say like whether the like
it's hard.
you know yeah. So it's like a very broad question. Like I think in general, like if you come to the conclusion that like you don't have enough data, like that's the problem. I think in general, you either have like a really small data set, like tens of examples, or you have your model is too complex, right? Because it's like the size of your data is only a problem like relative to like the complexity of your model, unless you're like trying to reach there's essentially like the performance you need, the complexity of the model, and the size of your data all kind of like have a relationship there. But yeah, so like, often if you don't have enough data, if that's the reason, probably means you're overfitting. But I would say in general, like instead of, I think data augmentation is like getting like very hot these days. And I think there's a lot of places where it makes a ton of sense. Like, I think there's a lot of ways we've figured out how to make it work with like images, for instance. Like a lot of times, like if you were to like rotate or flip an image in some way, it's like, it still makes sense. But I think for like a lot of other types of data, I don't think that we like know what sensible augmentations are. And like I see a lot of cases where people are trying to do data augmentation where like really they're just like the model looks like it's flailing because it just like can't figure out what the hell is going on. And so I think like this is somewhere where we need like more active research to figure out. I know there's a decent paper that talks about sort of like the causal relationships implied with data augmentation. And I think that that's like a good place to start in that line of research, particularly because like when you're augmenting your data, you are kind of like encoding in certain invariances you want the model to have. And so it's like we need to understand like for different types of data, and the answer to this question might be domain specific. For different types of data, like what are the types of invariances that are important to encode?
Okay. Guys, so does anyone have more questions for Skylar as well? Let's see. Oh, thanks for the. About the CI/CD process you mentioned.
Perhaps you can touch on it more. How do you perform CI/CD and prod for MLOps at LinkedIn? How do the tests and checks integrate with the CI/CD pipeline?
Yeah, good question.
Yeah, it's a great question. And the answer is they don't, largely. So while I was there, we had kind of set, like LinkedIn built their own sort of library to build ML pipelines. And we had kind of like just gotten that, like by the time I left LinkedIn like a year ago, we had like just gotten that sort of like the first production version of it ready. And so we did have some like we were kind of able to kind of like add some checks, but there weren't a whole lot we could use. But we did have something where like we could have an automated pipeline that would essentially like on a schedule retrain a model and then push it into production. Pushing into production is like not problematic. So it's not like if we don't have checks on something that it's going to like cause things to blow up. The place where things can become problematic is when you start ramping traffic to that model. And so generally speaking, to get something that LinkedIn had like pretty tight security controls. So you couldn't have like data scientists couldn't just like go and like make some changes to their pipeline and then like click go and then it would end up in production. You had to like go through code review processes and whatnot. Yeah. And there was even like a production review that had to happen when you made changes. And so it was pretty heavyweight anyway to get things there. But realistically, I don't think anyone actually checked to see, hey, did you like do all of these checks and whatnot? I think generally speaking, people like manually did a lot of these checks for like the model they built like with their pipeline in their own development environment. And then once people were like satisfied with what they saw there, then they'd say like, okay, we can just push that into production. It'll be okay. But like broadly speaking, a lot of those checks didn't really integrate into the CI/CD process. They happened like either before that in a more manual way, or it was like just part of like ongoing monitoring and whatnot that we had.
When you deployed, did you use like a canary deployment or something?
Yeah. So everything always like canaried. Yeah. So we always. Okay. Yep. So generally speaking, like LinkedIn had this principle called SQR. I forget what it stands for, but the whole idea was like it was basically the process for how we ramped things that kind of balanced risk and speed. And so essentially, like you always start with canary, then you do like an internal employee whitelist. So you kind of like give it to all the employees first, dog food it, and then beyond that, then you're supposed to do like 1%, 5%, etc. Yeah. I will say I didn't follow those guidelines too closely. I went much faster than that, but to each their own. Okay.
Skylar, I also have regarding tools. We haven't. Our discussion has been more like concept-wise, not really tools. Tools are just things we can use. It's not the most important, but nonetheless, what tools excite you the most currently regarding the MLOps atmosphere?
Yeah, that's a good question. In my last company, I used Databricks a lot, and I actually liked the experience of using Databricks. You know, I have this feeling every time I'm using like different MLOps tools, I can't escape this feeling that they're kind of too high level and they're trying to like handle too many things for me. So for instance, like I chatted with some of the YLogs people and they showed me their product for like model monitoring. And there was like a lot of things that were like decided for me, such as like the metric used to monitor. The metric that they had selected just didn't work very well for my data. And it didn't seem like I had like a lot of control over changing that. And I'm sure they'll fix that, later. But I just like, that's my common experience where there's like something that a vendor is controlling that they shouldn't control. And so I think like a lot of vendors are kind of like trying to attack this surface area of companies where maybe attack is the wrong word. They're trying to like get the market of people who like maybe just want something that just kind of works, and they don't want to like really probe it and really like make sure it works very well for their use case. And so I've generally just felt like the APIs that I see from Databricks, I feel like they've done a better job of, and don't get me wrong, like there's a lot of things I really dislike about the APIs that they have. It's not perfect, but what I will say is like I feel like they got the abstractions right, in that like for the most part, the things that they're taking care of are the things that I don't want to take care of and I don't care about, you know? Whereas a lot of these vendors, I feel like they're like solving part of the problem that I feel like you should just like let me answer that question.
Okay.
So yeah, Databricks is definitely one, and I'm definitely very excited about like anything in like the data-centric AI space. So Snorkel, Watchful, and I think there's like a ton of others, but definitely like watching that space to see how it grows. Very excited to see how I can apply that myself.
Okay. Regarding the Databricks, which APIs? The feature store, MLflow, which ones?
So the things that I use the most, I kind of trialed their feature store while it was like in beta. It seemed reasonable. So I generally liked it. But I think like the two key things I liked a lot were Delta tables. I think are a great abstraction. And then Spark is okay. I think Spark sometimes gets a bad rap from data scientists, but I think data scientists just struggle with distributed computation in my experience. If they don't have like the background, like a lot of people talk about the pains of like these errors I get from Spark that don't make sense. And most of the errors are due to something like serialization, which is like, just feels like a fundamental problem of like distributed computation to me. So Spark is fine to me. In MLflow, I liked a lot. There was some things that I didn't like a whole lot about it. It felt a little too hard to like customize metadata that I saved with the model. But broadly speaking, like I think like the abstractions kind of like worked fairly well, and I could figure out a way to support most of the things that I wanted to do. So it was like they were like lower level APIs, you know. And so I felt like the sort of like the things that it provided me and what I had to build on top of it, I think was a good trade-off. Whether it's worth the cost ultimately, that's another question that I'm still kind of like grappling with. I don't know, but definitely like the product itself was pretty compelling to me. It looks like Artem asked a question related to this. What do you think the reason vendors are implementing abstractions that don't solve your problems? Is it that they don't clearly understand who's their target user? I would not say that they don't understand the target user. I would say that it's more likely that I am not their target user is probably the thing. Like these people building these companies, like I don't think they're dumb in any way. You know, I just think that when you think of like I guess when you think of like ML competency across like the industry, like if you think of the people that are the most competent at ML and MLOps, I think that it's much less likely that those people will adopt fairly like complete solutions. You know, like Google is not going to adopt your ML platform at all. You know, LinkedIn's not going to adopt it. They're going to build it in-house. They're going to build it themselves. And so as you kind of like scale to the other end of like ML competency, where you get to companies that like have like almost no ML competence, but they kind of like need something that just kind of works out of the box. There's probably a lot more companies in that space. So when you consider like your total addressable market, I would, without doing any research whatsoever, I would imagine that there's much more like addressable market there. And these are people that like maybe like don't have as much of this like skill set to kind of like make those design choices. So these are the people that wouldn't adopt something like Databricks probably because they don't have that competency. And so I think it's just more of just like there's a different market they might be after. But you know, that does mean that like, you know, when these vendors reach out to me and say like, here, try my product, then I'm just like, man, this feels like a waste of time sometimes.
All right. Skylar, I think we're almost time. There's been a great hour. Before we go, I would also like to ask you some of your favorite books regarding MLOps, software engineering, DevOps, data science, the technical ones on top of your head that you would really recommend for us as ML practitioners to get better at our craft?
Yeah. So one that I read recently, there's a book called The Informed Company. This is more on the data side, but it talks about sort of like the evolution through like going from querying from source to data lakes to data warehouses, data marts. I thought it was a fantastic read. I thought it focused a lot on like what are some of the best practices you should think about there. I think for people like interested in like deep learning, especially with like PyTorch, I actually liked the Fast AI book. I thought that was great. Although a lot of people I think might argue that that's not production code, but that's a conversation for another day. But the machine learning design patterns book I think is great. Designing
Is it
data intensive.
A lot of TensorFlow? A lot of TensorFlow? You didn't feel that?
I didn't feel
DML design patterns. A lot of TensorFlow, no?
Yeah, I mean, I think it's like it kind of had a TensorFlow like edge to it, but that's not surprising given like the authors are from Google.
Yeah, exactly.
Yeah, so but I think like I think a lot of the patterns that I looked at there, like even though they're going to show you it and it's going to like lean towards TensorFlow, a lot of them didn't feel like they were TensorFlow specific. There are things that I think like are a little bit more broad. Designing data intensive applications, I think is just like, that is like a hallmark book. If you're working in anything data related, like as an engineer, you should absolutely read that book. It's fantastic. I feel like there's one more that I liked that I'm not quite sure of. There's definitely one more in my head. I just can't remember the name of it. But maybe I'll remember it later and drop it in the chat.
Drop it, please. Awesome, yeah. Skylar, awesome. Skylar, it has been a great hour. Before we finish, where can everyone reach out? Where can we meet you? How can we reach out to you?
Yeah, so I'm pretty semi-active in the MLOps community, so feel free to ping me if you want to chat. I'm always open. I'm on LinkedIn also, so feel free to jump on LinkedIn, add me, follow me. Yeah.
Awesome. Does anyone have more questions for Skylar? Or I think we can wrap this one up. Skylar, thank you so much for coming here today, man.
Awesome.
Really nice to meet you.
Bye-bye.